Hello everyone. In this lecture series we'll be looking into the sorting algorithms, and the first sorting algorithm that we'll look into is bubble sort algorithm. Now of the sorting algorithm, bubble sort is the simplest sorting algorithm, and the pseudocode for sorting algorithm is given as: if you are having an array A having n number of elements, then to sort this array the pseudocode is: for I equal to 0, I less than n minus 1, I plus plus. For j equal to 0, j less than n minus 1 minus I, j plus plus. And what we look into is adjacent elements of array A by using index j, that is a of j and a of j plus 1. So if a of j is greater than a of j, this thing we'll use in the case we want array to be in ascending order, and the reverse in the case we want array in descending order. If a of j is greater than a of j plus 1, then we'll be swapping a of j and a of j plus 1. Okay, so that's how basically the algorithm works. Now let us have one small example. So with that it will be clear. Let us say we are having array A with values 64, 34, 27, 14, 20 and 48. So total we are having 6 values, that means n is equal to 6, and corresponding indices will be 0, 1, 2, 3, 4 and 5. So as far as values of I and j are concerned, I goes from 0 to less than n minus 1. Value of n is 6. So I will go from 0 to less than n minus 1, that is less than 6 minus 1, so that is less than 5. So value of I will be 0, 1, 2, 3 and 4. Corresponding values of j. J is the inner for loop, and j always starts with 0, but it goes down till less than n minus 1 minus I, that is less than 6 minus 1 minus I. So value will be always 5, less than 5 minus I. Okay, so what are the values of j? Then depending on a of j and a of j plus 1, so we will sort it. So let's go with this. So initially we are having array A consisting of 64, 34, 27, 14, 20 and 48. Now for I equal to 0, corresponding values of j will be 0, 1, 2, 3, 4, that is j goes as less than n minus 1 minus I, that is less than 6 minus 1. Total number of elements are 6. 6 minus 1 minus I, so value of j will go from 0 to less than 5 minus I. Correspondingly value of I right now, that is at the first iteration, is 0, so less than 5, so that is up to 4. Okay, so at each iteration, or each value of for each value of j, we will check upon a of j and a of j plus 1. A of j, that means for j equal to 0, we will check upon a of 0 and 1. 64 greater than 34, it's true, so we will swap it. Then at j equal to 1, we'll check upon a of 1 and a of 2. A of 2 we are having 27, so 64 greater than 27, true, so swap it. Then for a of 2, that is for j equal to 2, we'll check for elements at a of 2 and a of 3. A of 3 we are having 14, 64 greater than 14, true, so we'll swap it. Similarly at I equal to 3 or j equal to 3, we'll check upon a of 3 and a of 4. A of 4 is 20, so 64 greater than 20, true, So here you go, get here we swap and we get 20 and 64. Finally, at j equal to 4, we'll check upon a of 4 and a of 5. A of 4 is 48 of 64 and a of 5 is 48. So 64 greater than 48 is true, so here it will be 48 and here it will be 64. So at the end of the first iteration, what we have got is the highest element, and that is stored at the end of the array. So that's how basically this bubble sort algorithm works. At each iteration, or that iteration we say as a pass, so at each iteration or at the end of each iteration or at the end of each pass, you will get the highest element. Okay, so at the first iteration we got the highest element stored at the last index, and your array now consists of, at index 0 you are having 34. Let me write index here only. At index 1 we are having 27. At index 2 you are having 14. At index 3 you are having 20, and then at index 4 we are having 48. So this is for I equal to 0. Then we'll go for I equal to 1. Now corresponding of values of j, what you do, you just remove this 4 and we'll go up to 3. So values of j will be 0, 1, 2, 3. Okay, again we'll compare a of 0 and a of 1. 34 greater than 27, true, so we'll swap it. Then for j equal to 1, we'll check at index 1 and index 2, that is 34 and 14. Yes, 34 greater than 14 is true, so we'll swap it. Now j equal to 2, we'll check the element at index 2 and index 3. At index 3 you are having 20, so 34 and 20. 34 greater than 20 is true, so 20 and 34. Finally, at j equal to 3, we'll check for index a of 3 and a of 4. A of 3 you are having 20, and a of 4 what we are having is 48. 34 greater than 48 is false, so this will remain unchanged. So now at the end of second iteration, we have got the second highest element. Rest of the array remains as at index 0 we are having 27, at index 1 14. Let me write the index also. At index 2 we are having 20, and index 3 we are having 34. Now next value of I is 2. Correspondingly, your values of j will be 1 less than the previous. In the previous we are going up to 3, so now we'll go up to only 2. So 0, 1, 2. So index 0, 27. At index 0, 27. At index 1, 14. 27 greater than 14, true, so we'll swap it. Then at index 1, you'll check for value of a of 1 and a of 2. A of 2 is 20. 27 greater than 20, true, so we'll swap it. Then for j equal to 2, we'll check a of 2 and a of 3. A of 3 what we are having, 34. So 27 greater than 34 is false, so this will remain as it is. So now at the end of the third iteration, what we have received is the third highest element. Okay, so what we get here, 48 and 34, these are our previous highest. Okay, so at the end of the third iteration, at index 0 we are having 40, at index 1 we are having 20, and at index 2 we are having 27. Now for next value of I, that is for I equal to 3, corresponding values of j will be only 0 and 1. So a of 0 greater than a of 1, false, so 14 and 20 will remain as it is. Then for index j of 1, so we'll check for index 1 and index 2. 20 greater than 27 is false, so this will remain as it is. So this is already sorted. So at the end of fourth iteration, we get the fourth highest element, that is 27, and other elements are 34, 48, 64, and now we are left with index 0, 14, and index 1, 20. Finally, for I equal to 4, this will be the last iteration. Okay, because here we got the values of I will go from 0 to 4, and we are gone for 0 to 4. So for I equal to 0, corresponding value of j will be only one, that is 0. So we'll check elements at index 0 and index 1. 14 greater than 20 is false, so this will remain as it is. So at the end of this fifth iteration, we have got the array which is in sorted order, and that too in ascending order. In the case you require this array to be in descending order, what you need to do is you just change only the symbol. Instead of saying greater than, say less than, so you'll get array in descending order. So that's how basically the bubble sort algorithm is. It's the simplest of all, but the only drawback of this algorithm is if you consider time and space complexity. So let us say we compute the time complexity. Our outer for loop, it goes from I equal to 0 down till I less than n minus 1 I plus plus. At every instant, value of I is getting incremented by 1. Inner for loop, it goes or it starts from j equal to 0 and go down till j less than n minus I minus 1, and again over here value of j increments at every instant by 1. And as far as your swapping code is concerned, that if logic and whatever this code, so this will get executed by some time only, maybe a few number of times. It may not that always it will get executed. All right, but now let us consider the time required. Outer for loop will execute n minus 1 times. As far as your inner for loop is concerned, let us consider the least value of I is 0. That means again, as j is starting from 0 and going down till less than n minus 1, even this for loop will execute at least once. Okay, and now let us say as far as this conditional statement is considered, let us say this get executed only k times. So total time required will be n minus 1 into n minus 1 into k. So if we expand this n minus 1 to n minus 1, it is n minus 1 whole bracket square, so that's nothing but n square minus 2n plus 1 into k. And last, if we expand this, it will be kn square plus, not plus, 2n kn square minus 2nk plus k. So the time complexity of this is nothing but, as it's a quadratic equation, time complexity is given as big O of n square, and this is what we say to be the worst time space complexity, time complexity. Okay, and this will happen in the case the numbers are either jumbled up, okay, or we have to sort the array in reverse order. So even if we consider the average or worst, it will be of the same type, that is big O of n square. And as far as best time complexity is concerned, this will get of order big O of n, because we are gonna at every instant we are checking two adjacent elements. At every iteration we are checking two adjacent elements. So minimum there are n elements, so best complexity will get in the case the array is already sorted, and in that case the time complexity will become big O of n. Okay, as far as your space is concerned, we take only one extra variable whenever we are swapping a of j and a of j plus 1. Whether we are entering into this swap either for creating an array or arranging an array in ascending or descending order, in either of the case we are taking one extra variable, due to which its space complexity is big O of 1. Okay, so that's it for this bubble sort algorithm. Finally, we do not use this bubble sort algorithm in the case you have to sort huge amount of data. Okay, because of this best and worst, worst and average complexity are of big O of n square. However, we can use it only in the case you don't worry for the space, and also in the case we require or you have the data of least amount. Okay, that's it for this session. In the next session we look into the other sorting algorithm. Thank you.